So we want to see what our aerodynamic components do to overall vehicle performance with both a typical track day enthusiast as well as a professional driver. Some of the things that we're taking out of the equation that a lot of people don't think about is traffic on track. For all intent purposes, we're basically the only car on track. Currently, we are the only few people here. Without traffic, we now can basically remove that entire part or issue out of the equation. A lot of people don't realize that traffic during track days actually really does impede lap times. Some things that we're going to be looking at on track are lap times, lateral Gs, brake pressure, throttle position, how long they're on the throttle. We're going to be looking at all that, and we'll go over that later on. But first, let's get back to the shop and check out how we set up the car with laser ride height sensors and sensored up the car. All right, guys, so we're back at the shop. We have worked on Justin's car just a little bit. We basically removed all his aero that he previously had. So he had our rear diffuser, our front splitter with the front splitter end plates on his car. We removed that because our first test is going to be no aero. I've also laid out the deck lid that we're using. Shout out to Sam Sullivan for helping us and giving that to us, I don't know, a year ago. We've really used the heck out of it. Thank you very much. We're going to be testing our very first unit, our wing that we ever made, which is the 8-inch or 200 millimeter swan neck wing. And then we're going to run our 250 millimeter curved blade wing that is hopefully coming out within the next few months. And we're just going to be trying to figure out, you know, how it performs on track and what changes they make to the vehicle's performance. So to do that, we're throwing an AIM Evo 5 on the car with both a professional driver and a track day enthusiast, and then we're going to record their feedback each time. The feedback will be opinion-based, of course. However, we will take it for what it is, feedback, and we're also throwing like I said, the Evo 5 by AIM on there with laser ride height sensors. So we're actually going to install this all over the car, so 3 units to create a base plane on the bottom of the car. And by creating a plane, we can tell how the car is performing on track. So we'll be able to use that to measure ride height at various locations to see what kind of downforce the vehicle's making. We'll be able to see how much lateral G is changing throughout the different setups. We'll be able to obviously track lap times and various other inputs like throttle position, braking, how much less or more they're braking. All those type of things we'll be able to look at after the track day beyond just regular lap times.